Pre-Calculus, Chapter 1, Lesson 2, looking at domains. I want to do 5 examples showing you how to determine the domain and how to express those using interval notation. We'll start with a fairly simple one, x squared plus 4. And remember, there's only 2 scenarios we have to look at when we're looking at the expression. Is there a denominator with a variable in it? In this case, no. Is there a radical in the expression? No. Therefore, because we don't have either one of those scenarios, then our domain is going to be all real numbers. There are no, that's an ugly color. No. Therefore, our domain is all real numbers, so this is what it would be. Okay, so remember, there's only 2 scenarios to look for. Variable in the denominator, and then a radicand in the expression. So let's take a look at this one. Oh, no, I don't want to do that one. That's kind of difficult. Let's go back. I'm going to go back to this one here. Okay, here I have 5 over x minus 3. So again, we want to look, do we have a variable in the denominator? Yes. So what do? I say the denominator, which in this case is x minus 3, cannot be 0. So x minus 3 cannot be 0, so x cannot be 3. So that's the algebraic way to express it. Now, in terms of interval notation, again, think about this. I think about this on a number line. I start over here in negative infinity and I go this way. So I start with negative infinity and I can go all the way up to the number 3 where I can't go any further because I can't use the number 3. Then I can start with 3. Let me put that at 3. I can go all the way up to 3, and then I can start on the other side of 3 and go all the way up to positive infinity. So I can start with 3, not included, and go all the way up to positive infinity. So this would be the domain of this function here. Okay, variable in the denominator. Here's our next example, x plus 3 times x minus 1. Now this is a scenario where what would make this 0? Because I'm multiplying this times this, I know that if either one of these is 0, that's going to create a 0 in my denominator. So in this case, I'm just looking for the 0, or using the 0 product property to determine what would make the denominator 0. So here, I can't use negative 3 in here because that would make the denominator 0. So x cannot be negative 3. Over here, x cannot be 1, because if I substitute it in 1, then that would make this factor 0, which would give me 0 in the denominator. So x cannot be negative 3 or 1. Now how do I express this using interval notation? Again, just imagine negative infinity, positive infinity. So starting down here, negative infinity, I can go all the way up to negative 3, but I can't use it. So I can go all the way up to negative 3, but I can't use it. Then I can jump on the other side of negative 3 though, and I can go all the way up to 1, but I can't use it. So I can go from 3 up to 1. Union with, and you can use union as many times as you need. I can jump on the other side of 1 and go all the way up to positive infinity. So I would go up here. So this would be the interval notation of this domain where x cannot be negative 3 and x cannot be 1 either. Okay, let's look at another example. Now in this case, I've got 2 things going on. I've got a radicand in my numerator, and I have this product multiplication going on down here, so I can't make either one of these 0. So again, I'll start with down here, so x cannot be negative 1, because negative 1 here would make this 0. Now this one can never be 0, and here's a little trick you want to remember. If you're squaring a number, every number squared is always positive. The only way to make this 0 would be if this value right here were a negative 1. And because this value that I'm putting in for x is going to be squared, this will never be negative, so this particular factor right here cannot be 0. So the only restriction based upon my denominator is x cannot be negative 1. Now I also have to work with this in the numerator. So I have to say that 4 minus x must be greater than or equal to 0. That's what the radicand tells me. And then I solve this. So I'm going to move the x over here. So I'm going to get 4 is greater than or equal to x. Now I'm going to flip this around so you can see, or it's a little bit easier for me to see, x, because I move over here, is less than, flip the sign, 4. So over here, x must be less than or equal to 4. Okay, that's part of my restriction, and x also cannot be -1. So again, I like to look at this as if I'm working on a number line. It kind of helps me see how my interval notation needs to be set up. So I start down here with -infinity, and I can go all the way up here to -1, but I can't use it, so I can go up to -1. Okay, in union with, I can jump on the other side of -1, and I can go all the way up to, now here, x has to be less than or equal to 4. So I can go all the way up to 4, but I have to stop there. So I can go up to 4, and 4 is included. So I don't have any numbers up here, so this would be my domain based upon those two things. Okay, so when you have denominators and radicals, you have to look at both of those together in order to figure out the domain. Okay, let's do one more here where I think we have a square radicand. Yeah, let's look at this one here. So I have a denominator that has a variable, so I need to figure out first x down here cannot be 3, because 3 would make this 0. Now I also have this up here. I have 4 minus x squared must be greater than, greater than or equal to 0. Moving this to the other side, I've got 4 is greater than or equal to x squared. Now I'm going to flip this around just because I like the variable on the left. It's a little bit easier for me to read. Now here we're taking the square root, so remember this causes this to be plus or minus 2. Okay, so again, because we had this x squared, we want to consider this as an absolute value, meaning that the value of my x must be larger or more than 2 away from 0. So let me just really quickly review that. So if this is 0, so my domain numbers that I'm using that have to satisfy this, I have to use values that are bigger than 2. So I got to use numbers up here, and here's 2 away from 0. I have to use numbers down here, so these numbers are in my domain. Okay, so now I'm going to use this to kind of help me out, remembering that I cannot use 3 either. So starting over here, I have a domain where I have -infinity. I can go all the way up to and include -2. In union with, now I can't use any of these numbers. I got to jump all the way up here to 2, and I can go all the way up to, but however I can't use 3. So I can go from 2 to 3, that's not included. Then in union I can jump on the other side of 3 and go up to positive infinity. So this would be my domain, taking into account both restrictions that are going to happen because of a variable in the denominator and a radicand. And then I have that special case where I have the x squared, where I have to remember thinking about that in terms of the value of the number being bigger than the value that I solved for. Okay, so those are some examples that should help you out in doing your homework.